Okay, today we're going to talk about proving a rhombus in coordinate geometry. Please make sure that you take out a piece of graph paper and a piece of loose leaf paper if you chose not to print out the notes. So the first thing that we need to go over is what are the properties of a rhombus. So the first one is that it has all the properties of a parallelogram. I know this is repetitive, but we're going to review them. That means the opposite sides are congruent. The opposite sides are parallel. The opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. And the diagonals create two congruent triangles. Now we have to think of what makes a rhombus special. The first is it has four congruent sides, which means this side, this side, this side, and this side are all equal. We can show that with four distance formulas. The second thing is that the diagonals are perpendicular. So if I drew my diagonals and pretend I used a ruler, we would have a right angle where they cross each other. We could show this using two slope. And the fourth thing that makes a rhombus special is that the diagonals bisect the angles, which means this and this are equal, this and this are equal, this one here is equal to this one here, and this one here is equal to this one here. So when we're doing our proof, very important, and this is where students lose points on the regions. The conclusion must say what the figure is, what your work showed, and what property that work proved. They are the most important part of the proof. So today we're going to prove our rhombus. So the first thing we're going to do, let's quickly once again review the properties. It's got all the properties of a parallelogram. It's got four congruent sides. The diagonals are perpendicular, and the diagonals bisect the angles. So like any other proof, the first thing that we're going to do is plot the 4 points. So we've got 1, 1, we've got 5, 3, we've got 7, 7, and we've got 3, 5. And that is W, X, Y, and Z. So again, there are several ways you can do the proof. I am going to show you the easiest way to do it, and the one that most kids usually go for anyway. So here, a rhombus, we know it's got 4 equal sides. So the plan here is I will use 4 distance formulas to show 4 congruent sides. Now for the work, the first thing we're going to do, write down the distance formula. Now the work, the 4 sides of this rhombus are WX, XY, YZ, and ZW. I'm going to hit pause while I do the work. You guys might want to hit pause so that you can try it on your own. Now, if we look at all the work that I just did, I notice that all 4 sides are the same length. So when I do my conclusion, what I'm going to write is, since the lengths of all 4 sides of quadrilateral W, X, Y, Z are all, and you can write either radical 20 or you can write 2 radical 5 because I simplified the radicals. So you're just going to pick one of those. They are all the same length, so they are congruent. Again, you have to pretend that the person reading this does not understand math, so you're going to say a quadrilateral with 4 congruent sides is a rhombus. Therefore, quadrilateral W, X, Y, Z is a rhombus. Again, I know this is a lot of writing. A lot of you think that this is not English class, it's math. However, this could be an easy 6-point question on the Regents if you just learn to write a plan, show all of your detailed work, and then write a valid conclusion explaining what your work showed. If you have any questions, please either email me or write them down and ask me next time you see me in class.